Well, here we are with learning how to divide radicals, and just like every other sort of operation we've done, dividing seems to be the most complex. If you remember fractions, when you divided fractions, that was always the part that was a little bit confusing. So it's going to be like that with radicals too. I would say this is the trickiest part. Adding, subtracting, pretty simple if you can simplify them. Multiplying is really pretty basic. Dividing is a little bit strange. We'll call it strange. Not hard, but strange. Okay? Before we start, recall that you can always multiply something by 1 and it doesn't change. Okay? And we can make that 1 look a little bit different. For example, if we said, let's multiply by 2 over 2. This is still 1, but now my fraction looks different. They are still the same, but they look different. Okay? This is something we're going to use with dividing radicals. Okay? So here you have an example, 1 over root 2. This is not simplified. Now you look at it and you go, how do I know it's not simplified? Well, you can't have a radical in the denominator. Because there's a radical in the denominator, we have to do what's called rationalizing the denominator. And in fact, that's the division. Okay, when I see this, it's almost like you don't think, well, that means 1 divided by root 2. This means I have a fraction. It is division, but I can't leave it like that because there's a radical in the denominator. So what I'm going to do is I'm going to multiply by 1. But I'm not going to multiply by 1. I'm going to multiply by root 2 over root 2, which equals 1. And the reason I'm choosing that is because that's what I see in the denominator. All right, now look what happens when I multiply. If I multiply the top, I get root 2. If I multiply the bottom, root 2 times root 2 is root 4, which is 2. Now you have rationalized the denominator. You no longer have a radical in the denominator. This is simplified. Okay, so let's try this one. Here you're going, okay, I have a radical in the denominator. I got to get rid of that. So what I'm going to do is multiply by 1. Okay, now the bottom is going to be easy. Root 7 times root 7 is 7. What about the top? This needs to be multiplied by both terms. So I'm going to get 5 root 49 plus 3 root 7. This can be simplified to 35 plus 3 root 7 over 7. All right, and that is rationalized. Now when you're to this step, you should always check, can I simplify? Well, if you were to be able to be simplified here, I would have to be able to divide the 7 into there, and I can, but the 7 would also have to go into this term. And you can't divide this. 7 doesn't go into root 7. Okay, root 7 is like, I don't know, 2 point something. It is not a factor of 7. Okay, so this is simplified. It's done. Okay, let's try another one. Now, before I do this one, I'm going to say there's actually 2 ways to do this one, because I recognize that root 18, I could actually simplify that to root 9 over 2, which is 3 root 2. So I could simplify it, but I'm going to do it without simplifying it, because I find that most of the time when you're doing questions like this, you don't right away see that something can be simplified. You just see a radical in the denominator, and you said, okay, let's actually multiply here. Okay, had a little technical difficulty there. I'm back. We're going to multiply by 1. Root 18 over root 18. So if I look at the denominator, that's just going to be 18. I mean, I could multiply 18 times 18 and then take the square root of that, but I already know this is going to be 18. And then I'm going to get 6 root 36 minus 4 root 54. 6 times 6 is 36 minus 4 times 9 root 6 over 18. which gives me 36 minus 12 root 6 over 18. Now that is complete, but we have a problem. The problem is this can be reduced because I see a factor here, there, and 6 can go into each one of those. So I'm going to divide by 6. Okay, kind of like 6 over 6. It's reducing. Okay, so if I divide 36 by 6, I get 6. If I divide 12 by 6, I get 2 root 6 over 3. And that's simplified. Okay. What happens when the denominator is a binomial? Well, here's where it gets really tricky. If you notice the denominator was a monomial. When it's a binomial, we have to go back to that difference of squares or that idea of a conjugate. Okay, notice those are binomials that are the same except for different signs. So what we're going to do, we're again going to multiply by 1, but we're going to look at this binomial and write its conjugate. And then since I want to multiply by 1, I write the identical thing on the top. Okay, so again, what's the step? Look at the denominator and write its conjugate. Okay, now let's see what happens. I'll do the denominator first because that's what we're worried about. This is 9 root 4 plus 12 root 2 minus 12 root 2 minus 16. And if you notice, the terms with the radicals disappear. You end up with just 18 minus 16, which is 2. And now you have no longer any radicals in the denominator. That's why we do that. Okay, this is definitely the trickiest thing in this unit. Let's multiply the numerator now. So this is 12 root 2 plus 16 plus 6 root 12 plus 8 root 6. Okay, now there's no like terms there, but I see I can simplify one of these. 6 root 12. Root 12 can be written as root 4 times root 3. So this is going to be 12 root 3 plus 8 root 6. And we're done if it can't be simplified. But it can. This 2 can divide into each of these terms. So I'm going to get 6 root 2 plus 8 plus 6 root 3 plus 4 root 6. All right. Let's try another one. You try this one, so take a pause. What are we going to multiply by here? 3 root 2 minus 2 root 3. Okay, so that's the conjugate of the denominator. Again, I'm going to multiply the denominator first just to make sure that I got it right. So 9 root 4. And since I know it's a conjugate, I know the middle terms are going to cancel out. I'm not going to write them. I'm just going to... I've done it correctly. I know that I don't need to worry about that. Okay. Numerator, I'm going to go 6 root 6 minus 4 root 9 minus 12 root 12 plus 8 root 18. Let's simplify this. So I'm going to get 6 root 6 minus 12 minus 24 root 3. Right? How did I get that? I took a root 4 out of the 12 and multiplied it. And then I'm going to get 24 root 2. And this is over 18 minus 12. Okay, 18 minus 12 is 6. And can 6 go into each of these terms? It can. So I'm going to get root 6 minus 2 minus 4 root 3 plus 4 root 2. And we're done. Okay, So we'll stop there. I'll give you a few questions to try.